Hello everyone, this is Dr. E, and for today we're going to be working on word problems involving right triangle and trigonometry. The challenge in most word problems is how to formulate the equation that will help you answer the problems that you're working on in mathematics. And that is what we're going to be working on today in our lesson on geometry with a hint of trigonometry or the study of angles and right triangles. So that's what we're going to be, or triangles, and that is what we're going to be working on today in our word problems involving one of the most popular shapes that we are working on in mathematics, which is the right triangle. In solving with the right triangle, we have learned that in geometry, we can find the area of the triangle using the formula 1/2 base times height. And to find the perimeter, all we need to do is to add the side lengths of our right triangle. We also learned in geometry that the sum of the interior angles of a triangle is equal to 180 degrees. And if we are going to be working with right triangles, we can use the Pythagorean theorem to find the side lengths of our right triangle. But sometimes, when we are given limited information about the right triangle, we're going to be using another type of mathematical techniques called Sohcahtoa, which is a mnemonic device that we use to be able to formulate our correct equation to help us find the parts of a right triangle, may it be an angle measure or the side lengths of the right triangle. So we will practice our word problem skill by correctly choosing which among Sohcahtoa are we going to use that will appropriately help us find the measurements that we are working on or finding in a right triangle. And in this right triangle, we have two missing sides, the hypotenuse and side A, and we are also given the angle A, which is 32 degrees. And this is important because angle A is the reference angle that we're going to be using to formulate our equation correctly. So let's start looking for the first of the two side lengths that we're going to look for, which is C, which happens to be the hypotenuse of this right triangle. So the first thing that we need to do is to be able to choose the correct formula for our word problem. So we are going to visualize our right triangle first. And in our right triangle, we are given theta, or the angle, which is 32 degrees. We are looking for this measurement, which is the hypotenuse, and we are given the value of this side of the right triangle, which is 15. And once we have these information, now it will help us figure out a way on which formula to use in our Sohcahtoa. So to be able to do that, let's label the right triangle that we're able to formulate based on our given problem. So x is our hypotenuse from the reference angle, and using this reference angle, 15 is what we call as the adjacent side. So we have two different legs in our right triangle. We have the adjacent side, which is right next to the reference angle, and we have the opposite side, which is not given or we're not using right now. So we're just focusing on adjacent and hypotenuse. So A and H. So A and H, A and H, and this is the formula that we're going to be using so that we can find the value of our hypotenuse. So Ka is short for cosine theta equal to adjacent all over hypotenuse. And now that we have the formula to use, we will replace these value using the given information. So theta is given, which is 32 degrees. So we will replace this by 32 degrees. Adjacent is also in the problem, which is 15. So we will replace this by 15. And hypotenuse is what we're looking for. So we will replace it by x. And now that we have cosine 32 degrees equal to 15 all over x, we're going to be using cross multiplication and replace x and cosine 32 degrees so that we'll have x is equal to 15 all over cosine 32 degrees. And now that we have this x by itself, using technology, we'll be able to find the value of this fraction by typing in 15 divided by cosine 32 degrees, and our calculator is giving us the value of 17.68. So x is approximately equal to 17.68 units. We don't know the unit of measurement, but this is how we're able to find the value of the hypotenuse of our right triangle using trigonometry and technology. So first, just like what I mentioned, you need to make sure that you have your right triangle with you so that you can choose the correct formula that is appropriate for the side lengths that we are working on. And in this case, we know that we have the hypotenuse and the adjacent side from the reference angle of 32 degrees. So we're going to be using ca or cosine equal to adjacent all over hypotenuse and replace those information with the given value that we have in our right triangle. And now we have cosine 32 degrees is equal to 15 all over c, and using cross product, we'll be able to replace the value of cosine 32 and c and switch their places so that c is by itself, or x, or whatever variable you want to use for this problem, and use the calculator to find the value of your hypotenuse, which is 17.7 degrees based on our formula and our technology. So 17.68 rounded up to the nearest tenths. That's why we had 17.7 for the side length of our hypotenuse. And now let's clear our triangle and focus our attention to side length A, which happens to be the opposite of our 32 degrees. And this is important because we're formulating our formula, and by understanding the right triangle and making sure that we are using the correct value from the information given, we know that we have O and A, and OH, AH, and OA. We're going to be using tangent in our formula. So the formula is now tangent is equal to opposite over adjacent. And now that we have our reference angle, which is 32 degrees, we will replace A by 32 degrees. And now by cross multiplication, we can use this technique. I'll show you. Using cross multiplication from tangent 32 degrees equal to A all over 15. Since I want A by itself, I will just do a single move of multiplying 15 and tangent 32 degrees, and now A is by itself, and using our calculator, 15 tangent 32 degrees. And since my graphing calculator is pretty powerful, by just typing in all these values in my calculator, I have 9.37, which is approximately equal to the side length A that we are looking for. And in some calculators, there are different ways on how to input your value. Sometimes you need to multiply tangent 32 degrees with 15 first, and sometimes you need to find the value of tangent 32 and then push enter and then multiply it to 15. So make sure that you know how to use your technology, because different technology has a different way on how they produce the answer that we are looking for. So now we know that side length A is equal to 9.4, and in my case I got 9.37 degrees, but using rounding up to the nearest tenths, I have 9.4 in our answer. So this is how we answer or use Sohcahtoa to answer problems involving right triangle. Now, let's move on to the two popular keywords that we use to denote angle in our word problem using trigonometry, which is angle of elevation and angle of depression. Angle of elevation and depression, to make it a little bit more visual, let's say I'm on top of the building. Well, not really on top of the building, but I'm on the third floor of the building. I'm looking at the car down below me, and I'm looking up to the plane, which is flying into the horizon. So when we are talking about angle of elevation, it is the angle formed when you look straight to the horizon. And if you want to look and find the plane that is flying on top of you, you're going to look up. And when you look up, that is the angle of elevation. So keyword, elevator, going up. So we have angle of elevation using this keyword. And angle of depression is when you are working on a word problem wherein from your line of sight, you need to measure the angle formed when you look down to the car. In this example, that is the angle of depression, which is what we usually see in some word problems involving trigonometry and angles. So those are the keywords that you will be seeing in some of the problems that we're going to be working on, similar to this one. So here, citing the top of a building, a surveyor measured the angle of elevation to be 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. How tall is the building to the nearest whole foot? And that is what we're going to be measuring, the height of the building. And in this particular word problem, it will be a little easier because the diagram is given in our word problem. So we know the given information that we have. Now we're going to use the diagram as well that is also provided in this problem. So in some word problems, the diagram is given. In some word problems, you need to draw your own sketch. So good thing that we have our sketch, because here now we're seeing it better. We're seeing the right triangle. We're seeing the given information. All we need to do now is to choose the correct formula that will help us find the height of the building that we are calculating. So here, we are given the reference angle, that's us, looking at the top of the building and hoping that we'll be able to measure it using mathematics. We are given the angle of elevation of 22 degrees because we look up from the bottom or the base of the building. And we are also given the distance from us to the base of the building, which is 300 feet. The 5 feet transit is basically given also in the problem, and we are going to use that later on so that we can add it to the calculation that we're going to be working on today. So let's draw the right triangle. So now that we know that we have a right triangle, we are given the reference angle, which is 22 degrees. We are also given the distance from us. This is us. And it's 300 feet. And we're looking for the height of the building. So this is the building. And we're going to be measuring it using trigonometry, because this is what is missing in our computation. So from here, we can now label our right triangle because we are given the angle measurement. We are given adjacent side. And we are looking for the opposite side of our right triangle. So, Sohcahtoa, A, O, A, O, A, O, A, O, A, O. And we found the formula that we're using because tangent is the only formula with A and O, which is adjacent and opposite. All we need to do now is to write our equation, which is tangent theta is equal to opposite all over adjacent. And we know that theta is 22 degrees. And we know that opposite is what we're looking for. And we are given the adjacent, which is 300. And by cross multiplication, we now have 300 times tangent 22 degrees is equal to x. And using our calculator, we'll be able to figure out the height of the building that we are calculating. So 300 tangent 22 degrees using our technology is giving us approximately equal to 121.21. So 121.21, and according to our word problem, we need to round it up to the nearest whole foot. So this is going to be 121 feet if we use the correct, you're not seeing it, so let's write it down. 121 is what we're using because we need to round it out to the nearest feet. So we have this value of our right triangle, but we're not done yet because all we did was able to find out the measurement of um, the opposite side of our right triangle, but we need to include the transit value, which is 5 feet, and we're going to be using that after we calculated tangent 22 degrees equal to opposite, which is A, and adjacent, which is 300, and using cross products or cross multiplication, we're able to formulate our equation for A, which is 300 times tangent 22 degrees, and using our calculator, we're able to find that it's 121.21 rounded out to the nearest foot, and we have 121 feet, which will then add it to 5 feet, which is the transit in the transit above the ground from that particular building. So we are now going to have 126 as the height of this building given the information that we have from this problem. So we have 126 feet of the height for this building, and this is how we use our formula, our technology, and answering word problem similar to this one. And for our new problem, we have a given building once again, and this building is 21 meters tall that casts a shadow of 25 meters long. We need to find the angle of elevation of the sun to the nearest degree. And here we have the height of the building, we have the length of the shadow casted by that building, but this time we're working on the angle of elevation that was formed by the sun to the building. So we're going to draw our right triangle here because unfortunately the diagram is not given, so we need to visualize what is happening here. So we know that we have the sun, and we know that we have a building, and this building casted a shadow, and this shadow that you're not seeing, let's see if I can make it bigger there so we can see my diagram. So there, better. So now that we have casted the shadow, and this is the shadow, and we know that the shadow casted was 25 meters, and the height of the building is 21 meters. We're looking at the angle of elevation of the sun to the nearest degree. So angle of elevation to the sun. So this is what we're looking for in this particular right triangle. So now that we know that we have the reference angle, and this is the opposite side, and this is the adjacent side, in reference to our angle of elevation, we now have Sohcahtoa to play with, and we have O and A, OH, OAH, and OA. So we are using tangent to formulate tangent theta equal to opposite all over adjacent. And now that we know our formula to use, we will replace that formula with specific information, and we know the value of opposite side is 21, and we know that the adjacent side is equal to 25. Theta is what we're working on, so we're not replacing it. It's x, so if you want, we can replace it with x because that's the variable we're using. So how are we going to find the value of x? We're going to multiply both sides by the inverse of tangent. And by multiplying the inverse of tangent, we'll get rid of tangent here, and we are now left with tangent inverse of 21 all over 25, which is what we're going to be using in finding the value of the angle using technology. So by using technology, this is tangent. That's not what we're using. So clear that. We're using second inverse tangent to find tan inverse of 21 divided by 25. And now we have 40 approximately equal to 40.0302, and that is the angle measurement that we are seeing. And if we want to round it up to the nearest degree measure, so x is equal to 40 degrees using our calculator based on the diagram that we have drawn from this particular problem. So this is the challenge for some word problems in trigonometry, creating your own visual and making sure that you are identifying the correct parts of the right triangle that will help you solve your missing parts in your right triangle. And this time, it was the angle measurement. So here's the diagram that we're able to produce without seeing the picture that we have here right now. We're finding the angle of elevation from the ground. So by using Sohcahtoa, we know that we are given the opposite side and the adjacent side. So Sohcahtoa tangent has the O and the A, and by using our values 21 and 25, we're now given tangent A is equal to 21 all over 25, but since we're looking for A, we need to get rid of tangent by A by multiplying both sides by the tan inverse, and now we have A is equal to tan inverse of 21 divided by 25, and using technology, we're able to produce that angle measurement, which happens to be equal to 40 degrees. So the angle of elevation that we are able to calculate it from this diagram is equal to 40 degrees. So this is how we work with word problems in geometry, right triangle, and trigonometry. And the challenge when we are working with word problems in mathematics is formulating the correct equation that will help us in solving our word problem. So it takes practice. And speaking of practice, here is your practice of the day. Not that, but this. You are working on a tree, a chipmunk, or a squirrel, and the acorn. So let's see if you can find the distance of the nut from the base of the tree given the information that you have in this word problem. So comment it down below and use your technology and your formula writing skill to be able to find the distance that we are calculating in this diagram. And that is how we work on word problems in mathematics, specifically on geometry with the help of trigonometry and technology. There's so many G's in that sentence, but that is what we're working on today. And to be able to be more confident when we're working with word problems, it takes practice. So make sure that you know the keywords and understanding that in mathematics, it's like learning a foreign language. You need to know how to use the language or the wordings that we are seeing in a word problem to be able to formulate the correct equation that will help us solve our problems in mathematics. This is Dr. E, and see you again next time. Bye!